important to have that diversity in the rural areas as well, because as you know, if you look at the urban heat island, it also matters which rural location you take into account. So here you can see one of the stations. Um, so as I already said, the reason why we did this is before we had mainly weather stations being WMO compliant in rural regions. We also had our urban stations in Ghent, but we saw that those urban stations didn't cover everything we wanted to study. So we wanted a network that's also covering, for example, data from lakes, big lakes, but also um, forests, and so we could compare also data from different cities. So we also um, went to other cities, and the only way to do this, because we wanted to install 50 weather stations at the same time, was using citizen science. We were quite a small team back then, and we thought by having some help from the schools in Flanders, so the northern part of Belgium, we would be able to accomplish this. So what we did is opening a competition where schools could subscribe and find the best location. In this way, we used the knowledge from the local people in their environment to have a place where the weather station could stand. Because for people who have installed a network, you may know, it's quite difficult to find locations where people allow you to put a weather station, but also where it's vandalism proof and so on. So with the knowledge of the local people, we were able to put them on good spots. And we had 50 weather stations to spread, but we got like 400 and over 400 proposals from schools to put our weather stations. So we had really the chance to choose the best locations to put them and have like a nice spread over the region. And it's not only the locations that school could propose, they also built weather stations. So we um, made like an IKEA kind of box where they got the instructions how to build a weather station. And we also invited the teachers to the university so we could give like a demo on how to build a weather station. And then they took the weather stations to their class, and so the students could build them and place them on the perfect location based on all the instructions we gave. And also in the schools, they follow up the measurements. So if something is going wrong, we get the email, and so we can interact with the school to solve the problem. And because we also want to give something back, we let them do the data analysis as well. So they use the data in class. So for this, we made some online educational materials. And our network started in 2019 measuring. So everything was there, and then the COVID pandemic hit. So the teachers were really happy that they had all those online materials to use in their online classes. And then after the COVID pandemic was done, we also wanted to keep the bond with the schools, of course, because we want to keep that strong bond because they are the first people who see that something is going on. And so we decided to go to the schools as well and give some talks. And this we do also by teaching university students how to present. So in that way, we can actually go to all of the schools by helping hands of our students that also get like education at the university before they go to the school. So the university students also learn how to teach. And maybe I'll go back. A result of this is they analyze the data for their weather station, and they come up with some conclusions, and then they create an info panel for their weather station to put it next to the weather station so the broad public is also informed. So what does the weather station measure? So it's a station that is equipped with the Davis Vantage Pro sensors. For some reason, the rain gauge and the anemometer disappeared from this image. Sorry for that. And the solar panel is mainly for the battery power. So we don't need connection to the electricity net. And on this way, we were able to really put it in every rural location. So also there's like one station in the middle of a lake, just on like a ponton. So it's like it doesn't need electricity because the sun is powering it. And recently, like 1 year and a half ago, we also started to equip the stations with black globes because our team is moving further in the biometeorology. So for this, we thought it would be good to equip multiple stations with additional sensors. And all the data is open, so everyone can use the data. And this has been done because the schools could immediately see the data of their weather station. So if you click on the dots on the map, you can have a look at the location. So here you can like tap on the arrows, and then you see, for example, the land cover around the station. And if you then scroll down, you can compare weather stations, and you can see the last 24-hour measurements of the stations you have selected. And then, of course, other scientists also heard about our project and they were interested in using the data. So we also created an API so people can use the data. Some schools and municipalities also use the API to present the data in real time on their website. And then we also just didn't want to do some community experiment. We also wanted to do science. So that was our main goal from the beginning. So in the last year, we published some papers on the data use of this network, and this is an example of the propagation of the sea breeze. So we could see that the sea breeze is going from station one near the sea towards inland, and you can see that the sea breeze is behaving differently as it propagates inland. And then we also see on this figure nicely the spread in the land cover differences. So it's actually a triangular plot where you have the percentage of water, impervious and pervious. You see that most points are on the line between pervious and impervious, and the more impervious, the warmer the temperature, of course, during the night. There are also some dots with water, but as you can imagine, it's more difficult to find locations with a lot of water, especially in our small region. Then we also used these measurements for corrections of mobile measurements. So with the fixed stations, with the diverse land cover around it, we developed a method where you can do some speed corrections. So as you move on, and the temperature, of course, changes, and you have to kind of get into account also the land cover when you correct those measurements in the mobile measurements. So this we did by comparing the land cover of the mobile measurements dots and the land cover of the station, the fixed stations of the blender network. And by comparing those land covers, and we created, we subtracted or added some of the temperature. And in the end, we can also, based on the land cover, then create maps of the urban heat islands for different times in the evening. And this is done for the city of Antwerp, and in the paper there's also the example of Ghent, so it works for every city. And then some months ago we gave a summer school, so many people of Europe came to Ghent to have a look at their urban data set. And we thought it would be important to let them do science. And of course, as you have your data set, often something is going wrong. So you need to do quality control, but you also need to do gap filling. And because many people are taking a lot of time to just do this, we thought it would be handy to have a package. So all young scientists who start with their project don't lose too much time with this and can just use the package we created. And it's currently submitted, and you can already use the package. It's open on GitHub. So if you're interested, please go have a look. And another thing we use the data for is for the evaluation of hectometric numerical weather prediction runs. So by this diverse land cover, we can also have a look at the measurements and then compare to the model output. So that was the science. What about the community? Well, it worked quite well because we learned that communication is very important and you really need to keep a strong bond. And it worked because out of this project, we were able to start some new projects. Municipalities contacted us because they were interested in investigating the effects of greening their city. So currently, we did measurements in the old situation. So it's some cities with very impervious surfaces, so paved square here, that will become a very green and climate adjusted square with some trees. So we're very curious what the effect will be of those implementations. So we do these measurements in 4 different cities in Belgium. So what have we learned and what do we want you to learn from this presentation? Citizen science creates novel insights and scientific possibilities. If you're not able to do something on your own, maybe think, can other people help me and do the work for me? And it's also striking for us that schools really wanted us to teach them about climate science. The students and high schools are very enthusiastic, and we hope we can also inspire them, and that they maybe stand here in some years with their own research. Further, the real-time open data is also like a game changer for our group because many people started to contact us about using the data. And also what we did is thinking on the long term. You often have the project money that is running out after some years, and that is also for us the case. So currently we are relying on local partners that are funding our project further on. So that was also through the schools. So now municipalities are paying some money for when an item would break down from the weather stations. And lastly, I want to say, don't underestimate the time you need to set up this, because we started this with 3 people back in the time, and when you get 400 submissions, it takes you a while to get through. So that was it from my side. If you have questions, please ask.
Thank you, Sara. Time for questions.
Thank you, Sara. I have a question concerning you said that you let the school have some kind of like liberty in the choice of where they would put the station. Did you make by any chance any survey of what were different things that they would consider important in setting up of their station? And did it change a lot between the different schools?
So to put their weather station, so we made a competition out of it, and we said we would only select the best locations, and we gave them some guidelines because we really wanted the network to have a diverse land cover and also be spread like nicely over Flanders. So we took that into account. So when the schools proposed the location, we really went for the schools that came up with crazy ideas like putting a weather station in a lake. So that's the answer to that. So they had the freedom to put them, but we didn't really ask them. Like, I could have a look like where they selected. Often there were also locations on the playground, but we said we don't want locations on the playground because it's not so representative for what we want to study.
And so did you have in mind also to complement the existing meteorological network from the KMI?
Yes.
From the meteorological, yeah?
Yes, yes.
Okay.
Yeah, I think time is up because we need to.
Yeah, people with questions, you can come after the session and ask.
At the coffee break, we continue. Thanks, Sara.